Okay, so let's do a slightly more complicated hypothesis test. And our hypothesis now, it'll be slightly more complicated because we have to be bit more accurate to get our p-values. Because we're getting closer to the actual observed value. So let's say our hypothesis is that p is equal to 0.25. So remember that we made 34 out of 100, so that's 0.34, and 0.25 is just a little bit less than that. And when it was obvious for 0.2, it'll be slightly less obvious for 0.25. So let's do a one-sided test. And so we want to look for data. We want to look at the probabilities of making 34 or more shots out of 100. Okay, so if it was two-sided, we might have to look at making a certain amount of less than, say, like 11 shots or something. But let's do the other side, because we actually made 34. And the probability of making 34, remember, is, so let's call it k equals 34. The probability is given by 100 factorial on 34 factorial times 66 factorial. So that's 100 choose 34 times 0.25 to the power of 34 times 0.75 to the power of 66. So we put this into Google and we get something like 1%, 1.1%. Okay, so if we just simply multiply that by 66, which is all the shots, all the possibilities for more than 34 shots, it's going to be like a big number, and that's going to be too big. But what we could do is we can keep moving to the right, looking at how the probability of making 35 shots, 36 shots, 37, until we get one that's small enough that we can kind of just stop caring about the ones down the end. So, for example, we could do probability of k equals 35 is equal to 100 factorial, 35 factorial, 65 factorial. And that is equal to, let's put this on Google, something like 0.007019. So that's like less, but maybe not small enough. And try p probability of 36 shots. So 36 shots. Alright, I'll just put it straight in. It'll be like 100 factorial over 36 factorial, 64 factorial, and the powers will be 36 and 64. Okay, 0.0422. Okay, so you can see like kind of these two added together is roughly that one. So they're getting smaller, they're getting smaller significantly. Getting significantly smaller. I'll do one more. 37, so that'll be 37 factorial, 63 factorial, 37, 63. Something like 0.002. Okay, they're kind of getting, they're almost like decreasing by half. So, still not enough, but it is enough in the sense that, see, these two added together give you roughly 1% something. So these two added together is 2% something, and 10 times this gives you 2% something. You could even go down, so all the way to 27 then. So P of k equals 27 is equal to, so change to 27 factorial and then 73 factorial. Something has gone wrong. It's very strange. Oh, sorry, I went the wrong way. That's right. Okay. Okay, so yeah, if we go all the way to actually 47, not 37. That's what I did wrong. Okay, good. 47. $53. Well, now you get like lots of zeros. 0.000 0.00118. So many zeros that if you times this by like 100, it still wouldn't make any difference. So this shows that the probability of getting 34 shots or more, it's certainly less than or equal to the probability of getting 34 to 37 shots plus 9 times this probability, which is bigger than the numbers from 38 all the way up to 47, and then the rest, however many shots there are, times this number, which won't contribute anything. So it is definitely significant evidence against the hypothesis. P is 0.25 when the alpha level or significance level is set at 5%.